lesson 3. We ask ourselves here is what happens if we don't have a majority when we're using plurality? Because someone can win with the most number of votes, but not have over 50% of them. Do you really want somebody in charge who only has 47%, but they had the most first place votes because there's some other people? Well, that's what we're going to do now. We're going to force a majority. And we're going to do that with plurality with elimination. It's also known as the instant runoff voting. All right, so question 1, how does one get a majority vote with 3 or more candidates? And that's the tough thing. If you have 3 or 4 people running, you might get someone who has the most first place votes, but only have 40% of the votes. So what happens if we want to get over 50%? Well, we start eliminating people. We eliminate the lowest, and then we have a runoff. And so that's where preference ballots come in, because now we don't have to have people physically come in and re-vote. We can just use our original ballots, the preference ones, so that we know who they want next. So our process is this. It's eliminate candidate with lowest first place votes. So that could be someone who doesn't have any. That will come up somewhere. So get rid of the person who has the lowest first place votes. Eliminate candidate with the lowest first place votes, whose votes will shift to another candidate. Step 2, repeat. So you're going to continually do this until a candidate has over 51% of the votes, or a majority. So here we go. We're going to use the plurality with elimination method on the same math club election. So in the first time we did this, plurality, person A won, they had 14. Then we did border count method, and we found out that B was right through the middle of all this, and that they would win using that method. So let's see who wins using this method. So to begin, since we're trying to force a majority, we want to know what is a majority. So 14, 10, 8, 4, and 1 adds up to 37. Okay, so if I divide 37 in half, I get 18.5. But you can't have 18.5 votes, because right there, that's also 50%, and I want over 50%. So majority would be over 50%, so that puts it at 19. This is the magic number that we're trying to hit. As soon as someone hits 19, we're done. Maybe that's the last step, maybe it's the second step, maybe that's even the first step. So let's start off. Does anybody have 19 votes? A has 14, C has 10. Actually, C has 10 plus 1, so they have 11. D has 8, B has 4, no one has 19, so we're going to continue. By continue, it means we're going to eliminate somebody. So who has the least number of votes? That's player B with 4 votes. 8, 11, 14, 4 is the least. So B is gone everywhere. So these votes shift to player D. So let's see if anybody has 19. A still has 14, C has 11, and these 4 votes went to D, so now D has 12. No one's at 19, so who had the least? D has 12, C has 11. So now C's gone. C's gone, 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 he gone. Alright, so let's see who these votes shift to. So these C pass B, and they go to person D. These votes pass C and go to D. We're only down to 2 people now, A and D. A has 14, so D actually has 10, plus 8, 18, plus 4, 22, plus 1 more, 23 votes. So D actually wins with 23 votes. D wins. Alright, with our next part, we're going to notice that there's kind of a glitch that can happen with plurality with elimination. So let's see what happens there. So here we have a straw poll. Okay, a straw poll. And we have A who has 7 votes, B that has 8, C that has 10, and A that has 4. So what's going on here and why it's called the Olympic problem is the Olympic Committee is voting on if they want to have the Olympics at Athens, Barcelona, or Calgary. And so they'd done this straw poll, which means it's not official yet. They just went around and started asking people to see what they would vote. And this is what came of it. So who would win this? Well, let's see. We've got, if we use plurality with elimination, we have A has 11, C has 10, B has 8. So that person's gone. B. And so who will these votes go to? They will go to C, which is Calgary. And so we've got 18 votes versus 11, so Calgary would win. So what we have now here in the actual vote is this last column thought, hey, I want to vote for the winning team. So they switch these two, and so now they are giving votes to Calgary. So Calgary is going to get some more votes over here. So Calgary now has 14 in this column. B has 8 still, and A still has 7, which is Athens. So now let's see who wins. Well, you got 7, 8, 14. Who has the least amount? A does. So A is gone, A is gone, A is gone. These votes go to person B. B has 15. Calgary has 14. So Barcelona wins? That's strange, right? I mean, the idea is, look, we gave votes, or these people gave votes to Calgary after they'd already won, but then they lost. How does that even make any sense? Well, that is one of the glitches with plurality with elimination, and that leads us to our next criterion. Okay, so if candidate X is a winner of an election, and in a re-election, the only changes in the ballots are in favor of X, and only X, then it only seems fair that they should be the winner. I mean, if the only points are given to the person who won, shouldn't they win the second time around? Well, a minute ago we saw that that doesn't always happen, which is really strange. And that really is one of the things that's wrong with plurality with elimination. So that's what happens with this. What's wrong with this one? It violates the Montanosity criterion, and it violates the Condorcet. So if we compared everybody head to head, this one wouldn't work criteria. That is one of the negatives, that quirk. Like, really, why would anyone use that? I mean, who uses it? Well, the Olympic Committee does. And quite a few other people do too, like various cities like San Francisco, Burlington, Vermont, Berkeley, California, and then Australia uses it to elect members of the House of Representatives.